Okay, everybody, basic integration rules. And a lot of the basic integration rules are going to come off of, I always say, keep that 100 integration formula sheet handy. Keep your calculus handy. Keep that trig formula sheet handy. All four of those formula sheets, I say keep handy, even though I don't have my trig one in front of me. I always like keeping them in front of me. There it is. All right, let's see what we got on here. So this is from the book, and once again, some more basic integration. I think you can find most of these on your calculus rule, and if not, you can find them in the 100 integration rules somewhere in there. So take a look at these. And we don't have this particular sheet. I don't know if I put it in anywhere, but if you want to print this out, you can use that also. I mean, you're going to see that you're going to have multiple integration sheets from different places then. I mean, with the same integration stuff. So this was from the chapter 8. And we're going to do these 3 problems in this section. If we look at this. All right, so, and it's kind of important to look at the difference of these. I mean, here we don't have an x on top. Here we have an x on top, and then we have an x square on top. So all 3 are done differently. Progressively getting harder. So let's take a look at 2A. What happened? Where's okay? I didn't want to show everything, but there we go. So the first one. If you look at it, you can see this x is normally the u, so u squared, and then this is 3 squared on the bottom. And if you bring the 4 out in front, you end up with, you can say a squared plus u squared, or u squared plus a squared. It's the same thing, where a equals 3 and u equals x. And then if you go to your formula sheet, the 100, go to your 100 integration formula sheet and look at number 23. And once again, every time you're doing a homework assignment or anything, and you're going to use one of these 100 integration formulas, I would put a little check mark next to it so you can say, oh, I've used that one already. So I'll probably be using it again. And this is the formula 1 over a squared plus u squared. And the formula converts to 1 over a. The 4 is out in front. 1 over a arctangent u over a plus c. So you just plug it in, and a is 3. Arctangent u is x, a is 3. And then we're done. I'm just going to distribute the 4 back in there. And I'm always writing sideways. I don't know why. And that's what we get. So, I mean, like I said, the first one was easy. The second one gets a little harder, and the third one gets a little harder. But that's you know, what did I say? Rule number, which one did I use? 23. Rule 23 from the 100 integration sheet. So definitely mark that one. I think we've used that one before previously.
Yeah.
All right, let's take a look at What's next? If it lets me. Okay. Now, in the next one, they show you, oh, I wish they put the problem up. There we go. In the next one, they show you, you can't use arctangent because you have an X up here. Arctangent, that rule 23, you can't have an X on top. I mean, unless it's part of the, well, you can't. You can't use rule 23 there. However, if you look, if we make the bottom, I already said that, the bottom u, and then the derivative of u is just 2x. They show that here. So we could say this is our du. But I mean, remember 4 is 2 times 2. So we can break that apart, and that's what they did in the next part here. They put this 2 on the outside, but they kept the other 2x there. 2 times 2 is 4. It's the same mathematical statement, and I just divided it a little bit. So this becomes du, and this becomes u. So we are integrating du over u. And anybody off the top of their head know the integration of 1 over u?
To ln absolute x squared plus 9?
Yeah, well, I'm just looking at this right now, but yes, there is a 2 in front. There is a 2 in front, but it's just ln u, and then plus c. So you end up with 2 ln, and whatever u was x squared plus 9. And looks like we are good to go. So that one wasn't too tough either, but you see the difference between no x on top. Okay, I can probably get a formula, something squared plus something squared. Here, there's an x on top. If there's an x squared on the bottom, oh, I can make the bottom u and take du for the top. So that's not too bad. The next one, I do see people have errors a lot. And the next one is, if I remember right, on the test. The next one is really similar to a problem being on the test. So if we look at this, and you recognize this right away, and they tell you the degree in the numerator is equal to degree in the denominator. The degree is the power of the x. If those two, if you have an x squared, or even an x3, if the degree is the same on the top and the bottom of the x squared, first of all, you can't make the bottom equal to u, x squared plus 9, because the derivative of x squared is 2x, and we have an x squared on top. You can't do that. So you have to approach this, way different. And what you have to do is, right here is a clue, you have to use long division. So you have to go 4x squared divided by x squared plus 9. The top divided by the bottom. X squared goes into 4x squared 4 times. Then when you do this, you get 4x squared plus 36. And when you subtract that, these two go to 0, and 0 minus 36 is a negative 36. So you end up with 4 minus 36 over the divisor. So this is how you get this part. You have to use long division. So you end up with 4 minus 36 over the divisor, which is x squared plus 9. Okay, so that shouldn't be too bad for an integration, because we should recognize, sorry if I erased that too quickly, you can integrate this to 4, and then you can integrate this to 36 over x squared plus 9. I'm going to bring the 36 out front. Well, first of all, integrating 4 is just 4x. And if I bring the 36 out front, I end up with x squared plus 3 squared, something we just did, we recognize. And this is rule 23. Once again, if you look at rule 23, and then you just have to label A and U. A is 3, U is X. And then if you go to rule 23, once again, it turns into 1 over, I gotta look at A, arctangent U over A plus C. Okay, so we're gonna plug this in. I end up with 4x minus 36. I'm gonna do this, 1 over 3, arctangent, A is 3, U is X over 3 plus C. And the last step is just bringing this 36 in here. 36 divided by 3 is 12. So my answer ends up being 4x minus 12 arctangent x over 3 plus C. So that's a little bit harder because you have to use long division. I mean, what you see here, the powers are the same. So you have to first divide these two using long division. And for some reason, people have a hard time with that. That algebra there, that's algebra. People do have a hard time with that. But you will see this. I mean, you do need to practice that. You will see this again. I'm sure of it on the test. Okay, and this is the final slide of 8.1. It gives you a little bit more clues on how to start doing some of these integrations. This is a nice piece of paper to have next to you while you're doing the homework and stuff. So it says, hey, don't forget, these are different techniques you can use. You can expand. In other words, you can, here, you can write 1 plus e to the x times 1 plus e to the x and distribute, and FOIL it. And that's what you get. And then you can integrate it. Separate the numerator. If you have a plus up here, you can say 1 over the denominator plus x over the denominator. And then work it. I mean, this is once again rule 23, something squared plus something squared. This is not rule number 23 because there's an x on top. You have to make the bottom u and the top du. So you see there's the differences. Completing the square, being able to complete the square. Here, half of 2 is 1, 1 squared is 1. So you would do 1 plus 2x, what is it, minus x squared. And normally you just put a subtraction here. That doesn't look right. This has to be a minus. And this is what where they are. Oh, this is the 2 there. And then if this is a subtract 1, if I put here, so I have to put a plus 1 right here. And so that's how they get the 1, the minus, and then this is a perfect square, 1 minus x squared. And that's how they get that. And now you have, once again, this rule 23 is going to come about a lot. This is a A equals 1, and then our U equals X minus 1. Oh, actually, it's not rule 23 because there's a minus there. If you look at, that's rule 24. 23 has a plus between them. Oh, wait, there's still more. There's a square root there. So it's totally a different rule. So you have to go, you have to find that somewhere. I mean, we're not doing that right now. It looks like rule 41 to me. Yes, it's rule 41. So, I mean, if I was going to integrate this, I would use rule 41 on my formula sheet. A squared, this is A squared, and this is U squared, and there's a minus between them in a square root. So rule 40, this would be then use rule 41 to integrate it if you look at all your sheets. And then keep on dividing. The powers are the same, so you're going to use long division, x squared divided by the denominator, x squared plus 1. And x squared goes in x squared one time. X squared plus 1. When you multiply that, you subtract it, you're left with a -1. So it's 1 minus 1 over the divisor. And that's what we get here. Adding and subtracting terms in the numerator. So you see the derivative. See, you can't use the bottom as u, because if the bottom in this one, if the bottom was u, x squared plus 2x plus 1, then the derivative of u is 2x plus 2. And you can't get a plus 2 up here. So somehow you have to put a plus 2 up there. And what they said is, well, why don't you just put a plus 2 up there, but then you have to subtract 2. So we're focusing on this part, you see? So now we're going to have the denominator with just this part, because this is now u and this is du. And then we have a -2 with the same denominator, and they're just showing you, hey, this is all, you can also change that denominator to x plus 1 squared. So, and so once again, you can make this u and then do the integration. So, I mean, they're just showing you, you can add or subtract numbers to try to get it. Especially a problem like this. This is really difficult because the bottom is u, you're missing the 2. So then you create another, you create that 2, but then you have to subtract that 2 because it has to equal the 2x, and then break it apart into 2 fractions like they did here, and then integrate it. Use trig identities. So definitely you can use trig identities. You just got to find the right identity. And a lot of times it's trial and error, unfortunately. A lot of times it's trial and error using that. Take a little practice. Multiplying divide by its conjugate. So, and this you'll see 1 plus sign, its conjugate is 1 minus sign. But if you multiply top and bottom by the same thing, you get the goal is to change the problem somehow to where you can do something with integration. Then this becomes, you can actually go into your formula sheet, and 1 minus sine squared is cosine squared, and then go through the problem. So 1 over cosine squared is secant, and then sine x over cosine squared x. And then this becomes u, and this becomes du. So there's, I mean, these are pretty good hints. These are pretty good hints on getting started or trying to find how to approach a particular problem. And you can see 8.1, I mean, there's a lot here. There's a lot here. So it's just going to take some practice. So let's try to get into the homework there. Let me get into the 8.1 homework. I don't even think I brought that up. I thought I had it up. I don't think I do. Let's get into it. If it lets me go into, there we go. All right, so number one, I actually looked at, I think yesterday, a student had asked me a question. I go, and it took me a good, I'm going to say a good 10 minutes to figure it out. It's kind of weird. Because of a trig rule I just had forgotten about. It says select the correct antiderivative. Antiderivative is the integral, right? So dy dx, so the derivative is this, and what we want to know is what happens when we integrate this. So let's just integrate that and see which one here is correct. X over x squared plus 36. Once again, an x on top. I can't use rule 23 or whatever. Yeah, 23 because there's an x on top. So as soon as I recognize that the power is only x on top, I'm going to make the bottom equal to u. And the derivative of u is 2x. So if I put a 2 up here, so I have du, I have to put 1/2 here. So now this becomes integrating 1 over u du. And anybody off the top of the head know the integration of 1 over u? I think I already asked that. Natural log of u. Plus c, so I put u back in there. And now we have to pick the correct answer. They want you to pick the correct answer, but this is what I got. So which one is the correct answer? A, B, C, or D?
A.
Okay, somebody says A. I'll just give somebody else a chance if anybody else wants to say anything different. See, it kind of looks like D also. We'll talk about this here in a second, but for some reason, I was stumped on this. It took me a good, well, maybe 5 minutes, a good Good 5 minutes.
I did the assignment last night, and the same question stumped me. I honestly thought it was a DS at first.
Yeah, but except there's this extra 1/2. So
Yeah.
what turned the light on for you, or did you just pick A and it was correct?
Isn't it the log powers that you
Yes,
use?
the
Yeah, that's
log
what I was
power.
yeah.
This 1/2 can go there. The power of logs. Remember, you have something in front of a log. That power can go there. So that's really the natural log of the square root of x squared plus 36.
So if by chance it was 1/8 in front, it would be the root to 1/8.
Yes,
for
it
the
would be
ln?
that.
Okay.
It would be that. And you don't put a 2 there for square root, but you put it for the 3rd root or 4th root or 8th root. Yes. So that's how it would be. Yeah. If this was an 8. But it's not. So there should be nothing there. It's an invisible 2. All right. Yeah. I wanted to show you that one because even I mean, it took me, wait, the rule of logs. If you remember when you expanded logs and natural logs and you put them back together, the number in front was the power. So yeah, it took me, back to trig. Let's see, what else did I wanted to do? I think you can go through these. I'm going to post this. I'll post this homework solutions for you also. I mean, look, question 2 is just a standard U du. Same way with question 3, you just bring the 9 to the top. It's a negative and then integrate it, add 1. Let's look at number 4. And if we look at number 4, we have an x times this. So if I go u equals the stuff inside of the cosine, then the derivative of u, bring the 2 in front, is 8 pi x. So I need to put, here's my integration, x cosine of pi x squared. So for my du, I'm missing 8 pi x. Now I'm missing 8 pi here, so I put 1 over 8 pi here to balance that out. Now this is du, and this is u. So we are integrating. What did I just do? Integrating cosine of u. And integrating cosine of u is the sine of u. It's 1 over 8 pi plus c, and then change it, the u back to whatever we had. It was u 4 pi x squared. Something doesn't seem right. What did I miss? No, that's right. It's the same answer that they got there. So that's not too bad. It's some people get confused because it's a little busy. What is a pi? It's just a number. It's just a constant. Well, it's a constant in there in front of it. 8.1. I think I wanted to do number 5 also. because number 5 was completing the square. So we want to look at number 5. And if you see they match up to what we did before, you see an x squared with an x in there. So you're thinking, okay, I need to complete the square, because I mean, in the that was part, I think, part of the PowerPoint, that part C, completing the square. Half of 10 is 5. 5 squared is 25. So we're going to put a 25 here. I mean, this is the way I look at it. Then we're going to do a minus 25. And then we're going to do, it becomes a minus 10x and a minus x squared. If we look at it becomes a positive. If I guess I won't do it that way. This is the way I look at it. We put a 25, we put a minus, and then we have everything inside here. But we have to change the signs. I think it's easier when we complete the square just to do it, put the 25 in there, which is what, 5 squared. Put the 25 in there. There's automatically minus in between it. And this is what you get. It's kind of hard to complete the square, which is 25 minus 10x plus x squared. So you end up with, oh, that should be minus. So you end up with 5 minus x when you factor it in, 5 minus x. So that's what you end up with, 5 minus x and squared when you do it twice. And there's that 25 sitting out in front. And we did that to now say we have an A and we have a U. So this becomes, that 8 went in front of it. So we end up with 8. Let me erase that because I can't see hardly anything when I write over it. We have the 8 in front. 1 over square root of 25 minus 5 minus x squared. And let's change that 25 to 5 squared. And A is 5 and U is 5 minus x, but then you have to say what's du, and du is -1. So we're missing a -1 for my du. So that's where this -1, all we have to do is put a negative here, but we have to, it's supposed to be positive, so we have to put a negative here. So that's, I think that part was a little tricky. And then you look at your formula sheet. Let me look, I think this is rule 41. I think this is one I looked at. Rule 41, a squared minus u squared in a square root. Yes, see, the same rules keep on popping back up. That's why I say mark them on your 100 integration sheet. Rule 41, and rule 41 changes when you integrate this, you end up with arc sine. of u over a plus c. So arc sine u, which is 5 minus x over 5 plus c, and there's a negative 8 in front of it. Okay, so this is an answer. And if you type this into the box here, because I tried this, and it marks it correct. Okay, if you look at the next step, they got rid of the negative and they changed this. The signs of those, they changed the sign of 5, now it's a negative 5, and they changed the sign of x, it's now a negative x. I'm recommending watching the watch it video there. They're talking about that being an odd function. So that's going back to trig when we learned about like arc sines, arc sines and arc cosines and arc tangents. About whether they're even or odd. And there's different rules for that. I'm not worried about that. On the show your work part of the test, I'm happy. This is the answer I want. And even the homework, they recognize this is okay. But they do show that these two are equivalent. And they mention because this is an odd function. It is an odd function. So I would go back, maybe just read on the trig about the odd and even functions on arc sines and on any arcs, and take a look at that. But I'm okay with this answer. We're good to go on that answer. So I don't know why they took it a step further and mentioned that. I mean, it's marked okay when you put it here. And I think that was the only other concern I had on 8.1. I mean, there's more, and I'll post the 8.1 solutions. And the rest of them are pretty basic. That's pretty basic. This one wasn't too basic. I mean, it wasn't crazy. You can see this becomes u, and that's du there. And you see where you're missing a negative 2x, and there's du. There's the negative 2x they end up putting there, and then just doing adding 1, and then putting it down at the bottom, and also it's not too bad of an integration either. All right, I think that's it for 8.1. Let me hit stop.